Last class, we popularized some for everyone. Mathematics knowledge in the game. For example, vector Euler angle quaternion difference operation. This knowledge, we will use it in this course. So, this lesson, let's work together to achieve the camera following of the character. We told you about that earlier. Common perspectives in games include first person, third person, and top view angle. That's the effect in the first person. First person game. The player's sense of substitution is very strong. It's an immersive experience. However, when designing, additional special effects processing is required. Special effects such as aiming and firing headshots. You need to open a separate line to deal with it. It's hard for everybody to learn. In addition, for beginner players, easily causes sandy vertigo. That's what the third person does. It is relative to the first person, increased part of the field of view behind the player. Players can observe some situations around them. Same. Third-person game. It also needs to add a lot of screen performance. That's why we chose the angle of view shooting game. One reason to explain to you. One is cost. Another reason, it takes into account the learning acceptance of beginners. And then finally, this is called the top view game. You find out. Actually, as long as you master a game design idea. Others are basically similar. It's just some extra special effects. No matter what perspective the game is from. In the game, the camera spends most of its time. They were all filmed with the protagonist. So let's think about that. How to achieve the role of the camera to follow. There are several issues to consider when the camera follows the player to shoot. First question. Target followed by the camera. Usually the player in the game. The main character. Second question. The distance between the camera and the target. Usually refers to the space between the camera and the subject. Straight line distance. The third question. The camera's angular shift from the target. That is where the camera is on the photographer. Here, you start by placing the camera on the person's head. Then focus on the photographer, the angle of rotation around the x-axis. Fourth question. Camera top view. That is, the angle of rotation of the camera around its own x-axis. Fifth question. Camera position difference speed. That is, within each frame of time, the distance the camera has moved. Usually used to control the camera to move uniformly. Sixth question. Camera rotation difference speed. The angle of rotation in each frame time segment. Usually used to control the smooth rotation of the camera. We create a new top view camera in the script folder. TS file. According to the analysis just now, add corresponding attributes. Due to our players, the initial default position is the coordinate origin. So, we will place the initial position of the camera, also set at the coordinate origin. Then adjust the distance and position relative to the player. So, we set a private offset variable. Set its initial value to Ling terms. Then on the camera node, hanging custom components in top view camera. Specific parameter value. Adjust according to actual scenarios and needs. So here's how camera tracking works. First, place the camera at a certain distance above the player's head. The camera is pivoted around the player's x-axis. Rotate backwards by an angle. The camera can be calculated relative to the player's desired offset vector. To prevent lens shake. Guaranteed smooth mirror movement. Use LORP interpolation to calculate the time frame within each frame. Camera offset position vector. Afterwards, add the player position vector to each frame time segment. Camera offset position vector. The desired phase can be obtained. Machine appearance location. At this moment, just set the above position to the camera position. To be on the safe side, it can also be at the current location of the camera and the desired location of the camera. Perform lob interpolation again. Rotation of the camera's top view angle. The principle is similar. Special attention is paid to camera follow needs to get the position of the following object. The position of the subject is changing in real time. So, you should get the location of the follow-up object first. Do camera follow-up. The position of the subject has changed. Occurs on update method. Therefore, the business logic of camera follow-up should be written on late update method. The camera follows the business logic. The reason why it is written on late update method. There's another reason. For example, suppose there are two scripts in the game. Script E contains update and late update. Script R contains updates. Then when the game is executed, each frame is divided into two corners. Execute the late update after the update is completed. Although executed in the same frame, but the update will be executed first. Let the update run late. Now suppose there are two different corners. Simultaneously control an object in an update. Then when one of the characters, when changing the orientation, rotation, or other parameters of an object, there's another script that changes these things. Then the azimuth rotation of this object. There will be certain repetitions. If there is another object in the update, if you follow this object to move and rotate, the following objects will shake. If it's a late update, we'll refer to follow the last position after all updates are executed, spin. This prevents jitter. The solid line principle is analyzed clearly. Code is not difficult. Create a new online update method. In this method, first determine whether there is a follow-up object. If there is no follow-up object, then return directly. First of all, place the camera on top of the subject. Position the camera relative to the subject's x-axis. Rotate back by an angle. Calculate the expected offset vector. Here we use the quaternion API, convert rotation angle to quaternion. Rotate the relative position of the camera above and the player. Vector. Calculate the position vector of the desired camera appearance. Then use the vector SandMod interpolation method. Calculate the offset vector of the camera per frame time. And finally, set the camera position. Where the camera is expected to appear. The location of the unfollowed object. Plus the offset in each frame time. The location of the camera. for the current location and the expected occurrence position. And finally, don't forget to set the camera rotation. Euler angle rotated by the camera around its x-axis. Get the quaternion. Then perform the difference on the quaternion. Interpolate the result. Set to the rotation value of the current game object. That is, set the rotation value of the camera. Then press Ctrl plus S to save. Test discovery. The camera will follow the player. Here, for more convenient follow-up node management, we put the original player node, renamed player model. Then create a new node. Drag the player model node under the player node. Then give the player node. Add a group character controller. previous player controls and animation controls. Leave it to the player node. This lesson, we mainly use vector Euler angles, quaternion difference operation, etc. Realize the camera's follow-up to the player. In the next lesson we will add weapons to the players.